Uh, Very important questions, right? First, you have to write a review for this. That's the main thing more than selecting the answer, right? So if you take 2027 paper, if you take the 2027 A-level paper, right? Okay, now see this. The first thing is uh, electromagnetic radiation with maximum wavelength is. That's the first question. Okay, now which one having the highest wavelength? Okay, they have asked electromagnetic radiation with maximum wavelength. Maximum wavelength means the minimum frequency. So how this order goes? How this order goes? Okay, give me a minute. So under this explanation, you write under dotted lines. Under the dotted lines, you write like this, right? Under the dotted lines. Uh, where is it? No, we got the paper, no? What happened to the paper? Certainly. Right. The first question: electromagnetic radiation with maximum wavelength. Right. The maximum wavelength electromagnetic radiation is right. What is the electromagnetic spectrum? It start with what rays, guys? Radio. Right. Radio waves. After that, microwaves. Then IR. Then visible light. Then UV. Then X-ray. Then gamma ray. So when you're going from this side, even this visible light, I can take like this. I can take VIBGYOR. I can take VIBGYOR. If I take as VIBGYOR, then how will it go? Highest frequency for violet. VIBGYOR. Remember this. This is the order. So if you go from this one, this side to this side, what happens? What happens? Yes, frequency. Frequency, new. New mean this is like Sinhala Payan. That is only new. Frequency. Frequency increases. Energy increases. Wavelength decreases. Then out of this highest wavelength should be whom? Radio wave. So underline radio wave. And in the dotted lines, you just write this explanation. Write this explanation. Okay. You write frequency increase from radio wave to gamma ray in the electromagnetic spectrum and show that how it changes. Okay. Tagal write this under dotted line. The online students, if you have this under number 1, you can write these things. Because the definition is important, what we call the review. Right. Right. Now the second question, right? Rutherford's, right? Okay. Now Rutherford's scattering experiment is related to the size of the, what is that? Rutherford, what did he do? Rutherford, he did what? Gold foil experiment. I gave this one, not it is. I'll give that. This side. Did you erase from this side? Right. Right. See the second one. Rutherford scattering experiment is related to the Rutherford scattering experiment is related to the size of the atom, size of the nucleus, size of the neutron, size of the electron, size of what? Size of the nucleus. Very good. Rutherford experiment, can you remember? So under this, you write a statement like this. Under this, Rutherford's gold foil experiment, under second question, Rutherford's gold foil experiment, most of the alpha particles went through the gold foil, some deflected in greater angles, little bit of alpha particles, little amount of alpha particles turn backward. Now we are in the second question. Turn backward. Came backward. Is it enough to write? Chutti letters filling, you have to write a chutti, beautiful letters. Came backward. Therefore, කොහේ හරි අස්සෙන් ගහගන්න, right? ඔහෙ මෙහෙ you write everywhere wherever you can, right? Therefore the conclusion is most of the atom is empty and the positive charge is centered in the nucleus. Most of the atom is empty and the positive charge is centered in the nucleus. That is the reason you have to write there. So it's related to the size of the nucleus scale. We are coming to an assumption. So answer is nucleus. If it correct, put correct. No? Correct, na? Haridagan. Right. Third one. The principal quantum number of an atom is related to the right. Quantum numbers, these things says these things. There are 4 quantum numbers, no? N, L, Ml, Ms. N says the energy level. Energy level says the size of the atom. Size. Again, when you take 2s, 3s, both 2s and 3s are same size. 3s is greater than 2s. So the level says the size. L mean sub energy level. Sub energy level says what? Sub energy level tells what? It tells what? Shape. It tells the shape of the orbital. What shape it is. Right? Its shape, whether it's spherical or dumbbell. D mean D shape. F mean F shape. ML mean it says the very good orbital orientation. It tells the orbital. Which orbital is it? Orbital orientation. In orbital, where is it? Orientation. MS says the spin direction. If it a clockwise direction, we say positive. If it anti-clockwise, we say negative. These are the meaning of this third one. Under third one, write these things. So answer is what? Size of the orbital. If it correct, put correct. Size of the orbital. Make a try kare nadda pota. You guys went to the same place? Different. Good. Number 4. Okay. Number 4. The orbital diagram wrote this writing. Online students, are you guys clear? You guys have the PDF, right? Online people. Because I didn't share the PDF. You guys have the PDF, so I'm just discussing this. Huh? Right. Right. Now, the next part. The orbital diagram in which both the Pauli's exclusion principle and Hund's rule are violated. What is Pauli's exclusion principle? Right? Pauli's exclusion principle, write like this. Pauli's exclusion principle, you just write PEP, right? PEP, Pauli's exclusion principle. Write it shortly, PEP. Under that, write same electron, same quantum number, cannot have, same quantum number cannot have for the 2 electrons. Same quantum number cannot have for 2 electrons. All 4 quantum numbers. All 4 quantum numbers, all 4 quantum numbers cannot have for 2 electrons. It means each and every electron has their specific or their unique quantum numbers. Then the next one is Hund's rule. What did Hund say? Yeah, first of all, electrons will occupy single, then only it will become double. So you can say electron under Hund's rule, you can write HR, Hund's rule. Under Hund's rule, what is Hund's rule? Electrons occupy singly, then it become doubly. Or you can say, in another way, you can say Hund's rule, electron will occupy the space to maximize the spin. Electron will occupy the space to maximize the spin. For an example, whenever electrons are filling, or it should fill like this to maximize its spin. If we draw like this, it shows what direction? Is a plus. What wise? Anti-clockwise කියලා we say. Anti-clockwise. Anti-clockwise name, I'm sorry. Clockwise. This we say what wise? Clockwise කියලා we say this. Are you guys clear? All right. So under this, now which one is, they're asking which one? Violated. Rules are violated. Now first one, what can you say? A diagram. A, can you see it's violated? Why? It has filled the second one, but didn't fill the first one. You can see that, right? The first, right? Okay. Now you can see this. It has filled the second one. Or second one has filled without filling the third one. B is correct, no? It's correct. C also correct. Why? First they have filled the 2SN. They have filled like this. D also correct. Then which one is wrong? First one is wrong. Answer is A. Okay. It's violating whose rule? Actually. Right? Both the rule. Why? Because can you see? In the A, electrons both are in upward direction. Then if it upward direction, these both are having what quantum numbers? These both will have the same quantum number. But if one is up, other one is down only, they will have 2 different quantum numbers. Therefore, they are violating both the things. Okay. Right. Number 5. The maximum number of 3D electrons having is half are 3D electrons. Okay. 3D electrons having is half. The maximum number of 3D electrons having is half. The maximum number of 3D electrons having is half mean 3D electron. 3D electron is half the belong how many electrons maximum? Only 5. Okay. S half mean there, that is MS. Actually, S means there MS. Actually, MS only we are meaning. MS half mean positive MS half. Because half things we are not writing for ML and all those things. No. MS half mean clockwise direction, how many spins can be there? 1, 2, 3, 4, 5. There can be 5 things there. Are you guys clear? Nice. Then number 6. The fourth electron of beryllium atom will have which of the following quantum numbers? Beryllium atom's fourth electron. Now we'll come for beryllium atom's fourth electron. Okay, we'll come for beryllium atom's fourth electron. When we come for the beryllium atom's fourth electron, come for the beryllium's fourth electron. Now beryllium's fourth electron, what we'll write? 1s2, 2s2. What is beryllium? 1s2, 2s2. Fourth electron means the last electron. Last electron, you have to write M, L, Ml, and Ms in order. How much is M? Which energy level? Second energy level. L mean S no puta. Again, L we say 0, 1, 2, 3. This is S, P, D, F. Now this S mean what I should put here for L? 0. ML mean 0 mean they have only one orbital, P and 3 orbital. You know these numbers, no? 0, -1, +1 here, just 0. So ML is 0. MS is, you can put plus half or minus half. You can put anything. Plus half or minus half is the answer. But anyhow, what they have given here, you can take plus half or minus half. There is only one answer. No? The answer is B. They won't give plus half and minus half both in one answer. Because I will tell why they are telling plus half and minus half. This reason will come in another MCQ question. All right. Guys, give me 3 minutes. I will come. Right. I have to tell a small message to them and I'll come. Give me 3 minutes. If you haven't tried the other questions, product try. Right. Right. Okay. Now, anyhow, when we see our school logos, we get a good feeling. Right. Anyhow, sorry guys. Just had to pass a message. Okay. Now, see the seventh question. The electron density between 1s and 2s orbital is. What is the electron density between 1s and 2s? Now 1s is here, 2s is here. How many electrons are between this? Zero. Answer is zero. Who wrote zero? You thought, what a hard question. Electron density. Don't know something floating. That's right. There is no electron between the orbitals. Electrons are situated within the orbitals. Electrons are not between the orbitals. It's situated within the orbitals. Therefore, the density is zero. Next question. Eighth one. These are very nice questions actually. A p orbital can accommodate up to, under that we'll write everything. Okay. May S, draw S and draw 2. Under P, draw 6. You just write S, no need to draw the electrons. S2, P6, D is what? 10, F is 14. Okay. Write like this. Okay. So number of electrons is equal to, okay, number of electrons. Electrons, number of electrons, and energy level, there is a connection. If energy level is 1 mean, n mean, number of electrons is 2n squared. This is a connection between the energy level and number of electrons. All right. First energy level, 2 into 1 square, 2. Second energy level mean, okay, 2 into 2 square is 8. Likewise, you can tell maximum number of electrons in each energy level. Right? Here, connection name just put, not much needed, but to write this one. Okay. Right. Rutherford's experiment, which established the nuclear model of the atom, used a beam of. Did he use beta particles? No. Did he use gamma rays? No. Did he use helium atoms? No. Did he use helium nuclei? What is helium nuclei? Alpha. Very good. Alpha is known as helium nucleus. Then write like this. Alpha is known as helium nucleus. 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 What is alpha mean? Alpha mean 4-2. Alpha mean 4-2. Alpha mean 4-2 mean, what does it mean? It has 2 protons, 2 neutrons. What is helium? Helium also 4-2. But helium has 2 proton, 2 neutron, and 2 electron. This helium atom. Helium nucleus mean helium 2 plus. This is only helium nucleus. Helium 2 plus mean it has 2 proton, 2 neutron. So helium 2 plus and alpha 4-2 both are same, right? Alpha 4-2 both are same because remember wherever alpha emissions are there, helium gas produced there. So you write like that. The places wherever alpha emissions are there, helium gas produced there. Okay, it means for an example, remember, right? If alpha 4-2, if it gets 2 electron, it can become helium. It can become helium 4-2 gas. Okay. Again, alpha, when it takes alpha mean helium nucleus, when it takes 2 electron, it can become helium gas. Okay. Can understand these things, right? Remember that. Therefore, answer is the same thing. Instead of alpha, they have given helium nuclei. That's it. Now the next one, number 10. The quantum number plus half and minus half for the electron spin represent. Answer: rotation of the electron in clockwise and anti-clockwise direction respectively. That is only the answer. We'll see the other answers as well. Okay, so there is definition is plus half shows just you put a definition like this. What's the definition for that? If you have a box like this, if there are 2 electrons like this, show this one is plus half, show this one is minus half, and show this one is clockwise, this one is anti-clockwise. Okay, rotation of the electron in that is not there. Magnetic momentum is not there. Two quantum mechanical spin states which have no classical analogs. Right? Okay. Actually, this is a nice question paper. Finally, you have to tell me how much you have got. Normally, we are discussing MCQs. MCQ discussion with description. These are good questions, no? Right. Okay. But you know him? Where is your brother? I didn't see him in the morning also. Here. Ask him to call me. Where is he? Ayya. Right. Next, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s1. This represent, right? Okay. Now see this. Okay. Now they have given the electronic configuration, no, guys. Okay. Now with this 1s2, 2s2, I'll write only the last two things. 3d5, 4s1. Now they have asked what type of electronic configuration is this scalar. They have asked. One, they have asked, is it excited state? Is it excited state? Right? Is it excited state? Is it excited now? What do you mean by excited? Excited mean? What do you mean by excited? Excited means, again, for an example, we'll say carbon. Now, what is carbon's oxidation state? Carbon's electronic configuration? 1s2, 2s2, 2p2. In excited state, what will happen? This S electron, whatever below level S electron, will go to other level. In excited state, it become 1s2, 2s1, 2p3. This is an example for excited state. Again, next energy level won't come to the below energy level. Excited state, what will happen? Below energy level will go to the next energy level. So is it right? Okay. Now, can you understand? Do you understand excited state? Excited state mean what? The below energy level person will go to the highest energy level. Electron transition will happen. That is only excited state. This is an example for excited state. Right? This is an example for excited state. This is an example for excited state. Right? Paper. Ask uncle. Right? Right. Now, this is a example for excited state. Right? And the next one is, okay, you can see they have asked second thing, ground state. C mean cationic form, anionic form. What do you mean by cationic form, anionic form? What does it mean? Right? Cationic form and anionic form. What do you mean by that cationic form and anionic form? Putha, see this 3d5 4s1. Is it a stable electronic configuration state? Yes or no? Yes or no? No. Do. Putha, can you remember chromium 24? Chromium 24, right? Chromium 24, what they get? 24 chromium, what they get here finally? Okay, S1, 4s1, 3d5, no? Putha, what is the state of chromium? It's the ground state. This is a ground state electronic configuration. Uncle is not there, right? It's a ground state electronic configuration. Why we don't say cationic form? Because if they're forming cation, Putha, remember, when they are forming, they form stable cation. If they're forming cation, they will remove this entire S1 and only they will form the cation. They won't spare an electron in cation. Have you seen magnesium forming Mg plus cation by keeping S1? No, right? Will aluminium, is it forming 2 plus cation? No. When they are removing, they will remove a wholesale. 4s1 means full 4s එක remove කරනවා. They will remove like that. They don't remove only one electron from 4s. එහෙම they don't remove. So using this, we are telling this is not anionic or cationic state or not excited state. Then definitely this is a ground state we are taking. right? So under that you can write like this. Okay, not excited, not simple A කියලා දාන්න, not simple A. Simple A mean excited statement. Not simple A because they go on not A. In excited state, electron will move from low energy level orbital to higher energy level orbital. Low energy level orbital to higher energy level orbital. Next one is put C wrong. C is wrong. C is wrong because you can write C wrong කියලා දාන්න. Under that, right? When they form cation or anion, they will remove the electrons in the orbital completely. They will remove or gain electrons completely. They will remove or gain electrons completely. Uncle Ullu Keku. They will remove or gain electrons completely. They will remove or gain electrons completely. Right. Eka clear? Ground state mean elemental state. At the element form, how they are. Ground state mean electronic configuration in the elemental state. Right? Ground state mean electron configuration at the elemental state. Nice. Next one. The de Broglie wavelength associated with a particle mass 10 to the power minus 6 kilogram moving with a velocity of 10 ms minus 1. Okay, de Broglie wavelength. What is the formula associated with de Broglie wavelength? Lambda is equal to, okay, lambda is equal to what? Lambda is equal to h over mv. Lambda is equal to h over mv. So lambda, h is how much? 6.634. That is a known unit. 6.634 into 10 to the power minus 34. J is right. J, joule seconds. This is only h. You can remember this value. 6.634. Have I given this? No. Have I given this value in this paper? No. Normally they give this in exam. But they have taken 6.63 only up. No, they haven't taken 4. So we'll take 6.63. H. M is how much? Mass 10 to the minus 6 kilogram. V is how much? Yeah, 10 ms minus 1, right? Put 10. So if you simplify everything, this is just only a small simplification. Here we have checked whether you can remember the formula. Whether 10, 10 to the minus 5, whether you get 10 to the power minus 29 kilo, you get the answer. Answer is D. Okay, 6.63 into 10 to the minus 29 meters. You have to do this working there. Huh? Explanation. All right. Number 13. Which one of the following grouping represents a collection of isoelectronic species? Okay. Which one of the following grouping represents a collection of isoelectronic species? Isoelectronic mean, right under isoelectronic, you write the word isoelectronic and write same number of electrons. Isoelectronic mean same number of electrons. Isoelectronic mean same number of electrons. Okay, same number of electrons. So same number of electrons, they have given so many things. Sodium, calcium, magnesium can't be same number of electrons. Why? Calcium is in a different period. Calcium different period. There it can't be. So B is isoelectronic. That is correct because N3 minus F minus sodium plus N3 minus configuration. You can write this configuration. N3 minus is what? 1s2, 2s2, 2p6. This N3 minus configuration. F minus configuration also this. And also sodium plus configuration also this. So they all having the same electronic configuration. They are isoelectronic. Then that is B. That's it. Okay. C and D nothing to discuss because they all belong to different periods. Number 14. number 14. This is number 13. We'll see the number 14. Number 14 is ground state electronic configuration of nitrogen atom can be represented by ground state of nitrogen atom puta. You know nitrogen is 1s2, 2s2, 2p3. So if you represent this, it is like this. Right? It is like this. So which one you selected as the answer? One only. C. C. C, no? C mean 3, 3. So 1, 1 and 4 only. Very good. Very good. You know that. Excellent. This is one. This way okay. Or even this way also correct. Because all the electrons can be upside down like this. Okay. All the electrons can be like this as well. Why you are telling? That's why we are telling. That's why we are writing plus half or minus half. Because when they are single, you can't expect they should be in the clockwise scale. Sometimes they can be in anti-clockwise also. These both are correct configuration. Answer is 104. Right? Okay. So you can write when the electrons are filled singly in an orbital, when electrons are filled singly in an orbital, when electrons are filled singly in an orbital, when electrons are filled singly in an orbital, the rotation will be clockwise. The rotation will be clockwise or anti-clockwise. The rotation will be clockwise or anti-clockwise. Clockwise or anti-clockwise. The rotation will be clockwise or anti-clockwise. Okay, nice. Number 15. Which of the following statements are correct? Which of the following statements are correct? Right? And which of the following statements are correct? You have 4 statements. First one, the electronic configuration of chromium is, that is correct. Argon's configuration with 3d5 4s1. That is true. Correct ne ahala tiyenne ne? That itself correct. Second one will say they have given A, B, C, D kila. Okay. The magnetic quantum number may have a negative value. Magnetic quantum number mean what? M, L. ML can have negative values, no? That is also true because there are d orbitals, there are p orbitals, dp orbitals can have negative values for this one. Okay. In silver atom, 23 electrons have a spin of one type and 24 of the opposite type. Silver is 47. Silver is a special electronic configuration. Silver 47. Now how we have to write this? 47 silver. Now we'll write this 47 silver. Silver 47. Now what is silver? This one 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Sorry, 3d10. 3d10. When filling 4s2 will fill first, then 3d10. Then 4s2, 4p6, 5d, 6x, 6s. Then 47 silver. Then 6s1, 5d10. I guess like this. We'll see. Count and see. 2, 4, 10, 12, 18, 28, 30, 36, 46, 47. Okay. This is silver. Silver is a person who is having special electronic configuration. Now they have said about the spin. Have a spin of one type and the other one is opposite type. You can't tell definitely which one is plus and which one is minus. Because even orbital can have like this. An orbital can be like this also. We can't tell which side spin kiyala, we can't tell that. Electron can have any side rotation. So in this puta, now see how many have one side spin. In this, now you can see in this 47, if you divide by 2, one side will have 23, other side will have 24. No need to write like this also. Can understand? You can see this one. In this, if you want to see like that, this is 1. This one will say positive side spin killer will take 3, 1, 3, 5, 1, 3, here 5, and this one. Then 1, 2, 5, 6, 9, 14, 15, 18, 23, 24, right? Then 24 one side means 23 other side. I think no need to write this, but I just explain. Right. So, fourth one, the oxidation state of nitrogen in HN3 is -3. HN3, nitrogen HN3 mean ammonia. HN3, HN3, no? I know it's supposed to be NH3, yeah? Wait. May HN3 is wrong. HN3, if you draw HN3, shall we draw a molecule called HN3? H is what? One hydrogen is 1, nitrogen, 3 are 6, no? Sorry, 9. 9, then 10. Then there are 5 bonds. HN3 is a molecule. There are 5 bonds. If you draw HN3, there are 5 bonds in this. HN3 should come like this, no? Right? There are 5 bonds in this. Right? How to draw the 5 bonds in this now? This is double bond. 1, 2, 3, 4. Right? Add the 5 bonds like this. HN3 should come like this, and this should be plus and this should be minus, right? This should be minus 2, 3, 4. Okay. Okay. This should be the atom. So here they have said nitrogen's oxidation number is -3. Nitrogen. So in this nitrogen, none of the nitrogen is -3. This is the best structure you can give for HN3, right? You understood, no? If you see the number of, because this is second period element. So second period, you can check the number of bonds using this, using their valencies. Hydrogen's valency is 1, nitrogen 1 valency is 3, then 3 nitrogen's valency is 9. Then you get 10 here. Then the number of bonds will be number of electrons are 10, number of bonds are 5. If the number of bonds are 5, right? So you can say 1, 2, 3, 4, 5. There are 5 bonds here. This is HN3, this not NH3, this is HN3. Right? You haven't seen this, but here this only this nitrogen has oxidation state. What is this nitrogen's oxidation state? -1. This hydrogen has +1. This nitrogen is 0. This nitrogen is 0. No, this nitrogen is what? +1. Oxidation number. This oxidation state, why? This is 0 because we got the plus charge, it get a +1 oxidation state. With this minus charge, this one get a minus oxidation state. Hari, you guys came here. Yeah. Yeah, if it that is for the Lewis structure. This, I think this is the best Lewis structure you can draw for this. If the Lewis structure is this, what you're telling is true. If the Lewis structure is this, then what you're telling is true. But this is unstable Lewis structure. This is not stable. If the Lewis structure is this hydrogen have +1, this nitrogen have -1, this nitrogen has 0, this nitrogen has -2. This one you got right. No. You got these values, right? You got these values, no? For the oxidation states. Okay, so this is the way. Can I understand? You can understand how to see oxidation state. So with these two views, which one is the best Lewis structure you can give here? Because since everyone is nitrogen, right? Okay, with everything is nitrogen. Here 2 atoms are getting plus charge. Here 1 atom is getting charge, right? For the nitrogen. Okay, then here only 1, but more than that, I think this is good. This is good. එහෙම ප්‍රශ්නයක් එනවානේ 5 bonds set වෙන්න. Yeah. 4 bonds only you are getting. හරි. මේක එපා. අරක ගන්න. Okay, number of bonds will be 5. හරි. So in the HN3 molecule, other thing is මේකත් එක්කම we'll go for the valency of nitrogen. This is a help for you. This number of bonds is a Lewis structure. Valency of nitrogen, Vn. Valency of nitrogen. We'll tell valency of nitrogen. This is A nitrogen, B nitrogen, C nitrogen. We'll go for the valencies, guys. What is the A nitrogen's valency? Answer is? Yes, please. What is A nitrogen's valency? Valency? See the bonds, 1, 2, 3 bonds. Then A bond, valence is 3. B nitrogen's valency? Mostly you forget this. What is the valency of that nitrogen? For valency, what are the things we had? Sigma bonds with other. For valency mean all bonds and only the ones. Lone pairs also. Then don't make a fruit salad. That is for hybridization only we get lone pairs. For valency, we remember, don't forget. Red color I have seen mostly students forget this. Valency, you add all bonds plus charges. All bonds plus charges for valency. Remember that, don't forget that. All bonds plus charges. Right? Are you trying a new one for that? Right. All bonds plus charges. Okay. If you put all bonds plus charges, what are you going to get here? For this one, what is the valency of nitrogen? B is 5. C is what? C is what one? C is 1, 2, 3. Okay. 2 bonds and 1 charge altogether 3. You said 2 minus 1, 1. Although minus charge, we add as 1. This is always I am repeating this again and again for the explanation. Please write these things, but include the valency also and write in highlight in red or write in red pen. Valency always people forget. They can ask this. So this fourth one is wrong. Then answer should go as 1, 2, 3. Fourth one 9, 3 things. Okay. Right. Right. Okay. Right. Okay. Anyhow. Okay. Now that's it. So we'll wind up the session. Okay. So we'll meet in the next class. Okay, you just tell your honest reviews. Online students, you just put a feedback for this. Okay, physical students, you just give your feedback here. Right. How